time is the mid-1980s. Michael J. Fox is going back to the future, and at this time, Ethernet switches do not exist. But bridges do. A bridge is going to make forwarding decisions at layer 2 in software as opposed to hardware. It's going to operate slower than a switch. We don't have ASICs, we don't have application-specific integrated circuits, but basically it works the same. A bridge, like an Ethernet switch, can make a forwarding decision based on a destination MAC address. And as we see on screen, we can have redundant links between these bridges. And today we could do this between Ethernet switches, but there's an issue with this, and we're going to expound on that issue over the next few videos. But what we have here is a layer 2 topological loop. We could have some really negative side effects if all of these links are simultaneously forwarding traffic. Traffic could just endlessly circulate around and around and around through all of these bridges. So while redundancy is a good thing, a layer 2 topological loop is a bad thing. But in the mid-1980s, Radio Perlman, working at Digital Equipment Corporation, develops the Spanning Tree Protocol, or STP. And a variant of that was later standardized by the IEEE, the Institute of Electrical and Electronics Engineers. That happened in 1990. The IEEE came out with the 802.1d standard. And as we get into our discussion of Spanning Tree Protocol, you're going to notice that we use the term bridge a lot, and that's because Radio Perlman, back in the mid-80s, working at DEC, that's what she worked with. She worked with Ethernet bridges, so the terminology used back then, it's still used today. Just realize when we talk about a bridge, for example, we might mention a root bridge. In today's modern networks, that's going to be an Ethernet switch, but we can still use that terminology of a bridge. Let's get started with our discussion of the Spanning Tree Protocol by understanding why is it a bad thing to have a layer 2 topological loop.